Thanks for the introduction. And today I'm going to give a very quick overview about the OpenTimer project, which I submit to the LeapCode Student Design Contest this year. And this work is joined with my partner, Chun Lin, and my advisor, Professor Martin, from the EC department in the University of Illinois at Urbana-Champaign. So the motivation of the OpenTimer project is pretty much from the prestigious ACM contest. So I guess it's out of power. Yeah, the motivation of this project is from the ACM Tau contest, 2015 to 2016. And we are trying to build an open source STS static timing analysis engine that can support the incremental timing and CPPR common path pessimism removal by default. The goal is because we know the incremental timing is pretty much the integral component of every STA engine, because the incremental timing the STA timing is typically used as the inner loop for many optimization-driven applications. For example, like the timing-driven placement or timing-driven routing, they usually incorporate a timer inside the loop for the timing-driven optimization. So the incremental timing is one of the main goals for this project. And meanwhile, we also want to find a parallel programming solution that fully utilize the multi-threading to both support the parallel full timing and incremental timing analysis. And this slide shows the very general architecture of the OpenTimer. Some of the future highlight is the OpenTimer is majorly written in C++11 using the modern software technology, especially the threading library. And we support the industry format, like the Verilog file, .v file, and parasitic spec file, and SDC synopsis design constraint as a timing assertion. And we also support the library for the delay model. And we can also pass the layout file from the left and depth, which are pretty famous for, well known for the placement and routing. And the central engine, as I mentioned, the central engine of the OpenTimer is the static time analysis engine. We use the parallel pipeline to schedule both block-based and path-based timing analysis. And all those incremental timing tasks can be run in a pipeline manner, level by level, so we can fully utilize the multi-threading to run those timing analysis, timing task propagation very efficiently. And by default, the timer is configured with CPPR. And I don't want to go too much detail because I do not have too much time. This slide just shows a very overall performance of the OpenTimer comparing with two state-of-the-art, iTimer C and IIT Race. And these two works are also the top two winners from previous Tau contests. And as you can see from this table, the left-hand side of the table show the benchmark statistics. And some of these benchmarks are from the open core design, and some are generated by Mental Graphic and Synopsys that have been used widely in other CAD contests. And in general, by the way, the golden reference we compare the accuracy is generated by the IBM Einsteimer, because IBM was the host of the contest. And in general, the OpenTimer can get a full accuracy using a very fast runtime with a very reasonable memory. And this trend is very clear in some of the very large benchmark with median gates and nets. And you can see in this benchmark, the performance of the OpenTimer can even get more than an order of magnitude in terms of runtime and accuracy. Just a little bit more detail about the performance and on the runtime. And the top side of this slide shows the scalability of the incremental timing. As you can see, as the number of incremental processing steps increase, the speed up, the runtime speed up of OpenTimer over the state of the art can even reach more than 2 orders of magnitude. And this is because the central engine of the OpenTimer is essentially a parallel pipeline. So all the timing tasks can be scheduled very efficiently in a pipeline manner. And even in the very first iteration, we can even achieve 2.7 speed up over the state of the art, in which we only construct the timing graph, pass all the file in a parallel manner. I guess that's it. And I do have a poster outside, so feel free to reach me out if you have any more questions.
Yes, thank you very much.